Can you believe we're starting Unit 2? A lot of people really love Unit 2. It is going to be a bit larger than Unit 1, and it's going to have a lot of new terminology, but it's really interesting. So our goal here is just to understand how statistics are gathered and how they're calculated. We see studies and data coming at us at almost an infinite speed these days, and we need to be consumers of it in a way that we take in what we can see as true, question things that sound questionable, and then just downright turn away things that are full of holes and all that fun. So, interestingly though, we're going to use the term statistics to be both the science of getting the data, collecting, organizing, and interpreting, and the actual data itself. So this could be the process, the graphing, or it could just be the numbers. That's all going to be called statistics. We're going to start in section 5B. This is a great e-text section for you to check out. If this video isn't quite enough, we start with 5B because it's a little bit more of an overview of the big picture here in Unit 2. So, can you trust the data? We're going to ask 8 great questions. Some of them are multiple part questions, so we're going to cheat, but about how to trust data that you have been handed. So the first thing is, by looking at what I can see, can I identify what their goal was in this study? And if I can, did they actually do the best thing possible to do it all? Like to pick people that asked the questions they asked. And I know what you're probably thinking right now, you know that meme someone shared with some random numbers on it? You don't know what the goal, who, what, when, where, why, or how. That's why we should probably quit sharing that kind of garbage, right? We're talking about real data here, not some weird meme. Now, there's funny memes. This is not about that. Okay, so what was the goal of the study? That should be clear. Like, I'm trying to show how people get sick, or I'm trying to show how effective some treatment is, or I'm trying to show how much better this battery is than the other battery. Can we tell that? What was the population? And from that population was a representative sample selected. So a population, this is a very important definition, is the complete set of people or things that you're going to study. This is the big picture. Everybody is in the population. Now, this isn't always going to be, though, the population of the world. So if I wanted to talk about how Arkansans view something, my population would be Arkansans. If I want to see about college students, my population could be Arkansas Tech college students. It could be college students at 4 universities. It could be college students in the South. Depending on what the goal of my study is, depends on who I actually want to study. But we can't actually study the whole population, so from there we take a sample. This is what's called a subset of the population, and that's where we're going to actually get our data from. So notice up here they use this phrase representative sample. There's lots of samples, right? If it's just a subset, it's people out of the big group, or animals out of the big group, or carburetors out of a big group of carburetors. But how we pick it determines whether or not the data from that is actually representative, actually shows us anything about the population. Okay, so why do we sample? Lots and lots of reasons. For one, why do they take a blood sample? Because if they took all your blood, you'd be in bad shape, right? Also, rarely do we try to talk to everyone. The census is one change to that. The census does try to talk to everybody in the United States. But that's extensive, right? There's a reason that's only done every 10 years. And we know it's not 100% accurate because there's no way to actually get a hold of everybody. So we sample to save time, to save resources, and time is actually a really big one there because people are fickle. So if I was surveying people and I surveyed people for 5 or 6 years, my data actually isn't really that helpful anymore because people change a lot in 5 or 6 years, or hours, or minutes at this point, right? So, was a good sample taken? And you should be able to tell. They should share that information, and when people don't share that information, I'm a little curious. The other part of that question is, can I identify the goal of the study and did they do it well, was what kind of study was it? And so we're going to get more into these types of studies, but I want you to recognize that they could just be doing some kind of observational or retrospective study. where they're just looking at and measuring things. They could be doing experiments, like good experiments or bad experiments, or they could be surveying people. How is this data coming? Okay. So observational study, I want you to start thinking about the word observe when you see that, whereas an experiment is somewhere where we apply a treatment and then observe. So whether we're just seeing what happens or we're kind of affecting what happens is the difference in those two. Hopefully from a retro, you can tell what kind of study a retrospective study is. So I'm going to give you 2 more definitions, and we're going to work an example here. So population parameters are numbers that describe the population. You see all that alliteration there? P. So we said population was the big group, so parameters are numbers that describe the big group. Usually this is the final goal of a study. This is not something that's known. Sample statistics, there's our friend statistics that we've talked about before, are numbers that describe the characteristics of the sample. So this is numbers you're going to get from the actual data you've collected, right? Because the data comes from the sample. That data is the statistics. Isn't that great? So let's look at our example here. We have a recent telephone poll of 997 randomly selected women in the United States revealed that 5 in 10 women believe there has been progress in curing cancer for the last 28 years. So this is who we've talked to, 997 people. In that, 5 in the 10 believe. So what kind of questions are we going to see? All kinds. Let's start here. What is the population? So remember, population is the big group. And what is the sample? Remember, sample is where you're going to get your statistics or your data from. So I'm actually going to start with this question. What is the sample? And to answer this, you need to answer, where did the data come from? Because we should be asking the sample. So we asked, well, we didn't, somebody, 997 women. So that is our sample. All those people were asked the question. That's where we got the data. So what does that mean the population is? Well, if we've asked women, well, where did we get those women? We got them from, well, let's go back and read it. These women all came from the United States. Okay, so when you go to do population, don't get too carried away. We know this isn't the population because that's the sample. If we're talking to women in the United States, does that mean we're asking all women in North America with cancer? No, for a few reasons. One, we can't just ask United States people and expect it to reflect North America. And 2, we've talked to people. Did it say anything about our numbers just being people who had cancer or just randomly selected people? Ooh, we're going to read these carefully, right? How about 5 out of 10 women in the country? No, we didn't ask every other person in the country. So what's our population? All the women in the country. That was where we got our sample from. Did you listen to that carefully? So our sample came from all the women in the United States. Our sample was 997. Right? Now let's figure out what the statistic is. So, is this the percentage of all the women in the country who believes there's been progress? Nope, because we don't have data for all the women in the country. Is this number? Nope, that's the actual sample. Is it the proportion of the 997 women who believe there have been progress? Yep. That is our sample statistic. So we have data about that 997, and we know half of them said there were some kind of cure. Feel like there's some kind of progress in a cure. So sample statistic has to come from the sample. So it has to be a number describing how that sample responded. Last question. I want you to notice just a little bit of change in terminology here. What was the population parameter? So we're going to take the sample statistic and apply it to the whole country. Okay? So, does that mean everybody in the country? Sure doesn't. Does that mean this 997? No, we know that's our sample. Is it the proportion of the sample who believed? Nope, that's the sample statistic. Is it the proportion of all the women in the country who have believed? Yes, that is our parameter. Okay, so I want to see the flow of this. We asked this subset, so that's our sample. This subset reflects all the women in the country, so that's our population. Of that 997 women, this is the data we got, so that's our sample statistic. And then we apply that to the population to show the population parameter. Isn't that crazy? Who knew there were so many steps in that, huh? So that was question number 1. Question number 2 isn't really a question. It just says consider the source. So we would like subjective data, but that's not always the case. People aren't always subjective, sometimes out of spite and sometimes out of accident. So who's gathering the data? Who's asking the questions? Who's making the inferences? And are they doing so without bias? So we're going to learn that bias is any kind of problem in the design or the conduct of the statistics study that favors a certain result. If someone is very, very involved in the situation but doesn't and has, I don't know, some kind of investment in how it turns out, them asking questions, them making inferences is kind of risky. Okay, we see the things we want to see, intentionally or unintentionally. So this really is why you see companies hire like secondary companies to come in and do their research, is because they can come in without bias, without this tendency to see the same problem they've always seen or the results in a clear, truthful manner. That's not the only type of bias we'll see, though. It's just someone being unsubjective. We could also see bias in how they've picked a sample and other things. But this is where we're going to focus on, like, did they pick the sample well? Okay? We like randomness when we pick out a sample, but samples without randomness are almost always biased. So if you've seen like a call-in poll, people who feel real strongly call in. Other people are quiet. Like those people in the mall who just stop and ask people that look like they might answer, that's a biased way to get a sample. Because here we've got some kind of choice in them instead of randomness. And you're like, well, I could choose randomly. You actually can't. We actually stink at being random ourselves. All right? So, introduction to all of this. What are we talking about? We're talking about data coming at us and whether or not we can trust it. So, can you identify from the situation that you've been given, the data you've been given, what their goal was? And if so, did they carry things out the way they should? We should be able to tell the sample and the statistic, and therefore the population and the parameter. Was the source subjective? Did the ice cream company tell you their ice cream was great, or did someone else? And did they get some kind of random sample, or just some kind of convenience people to ask? So to pick up in our 8 things we can ask to see if a study is good and look at, we're going to look for problems in defining and measuring the variables of interest. So you've probably heard the phrase variable before. It's some item or quantity that can vary or take on different values. So this could be in the world of qualitative data or in the world of quantitative data. And we're going to watch out for what's called qualitative data, because these are often more difficult to define and measure. So a variable, like we said, is any item or quantity that can vary or take on different values. But a variable of interest in the study are what we're actually trying to study and measure. There's another type of variable in the study we're about to see, but you're going to first look at what are they trying to describe, measure, define in this problem, and then have they done it well? Does that variable mean the same thing to all who participate is really important. And then how about everyone interpreting the results? How are they going to measure that? Things like safety or employed should be clearly defined. At first you're like, employed is pretty easily defined. But is it? Is someone who works 3 hours a week need to be qualified as counted as employed here? Are we just talking about full-time employed? Are we trying to compare employed people to people who wouldn't even be in the employment? Are we just talking about people who want to be employed but aren't employed? So there's a lot of little caveats in there we need to catch onto. And safety, are we talking about no one getting hurt? Are we talking about no one dying? Are we talking about people feeling safe? Like, how do we define that? And also, how are we going to measure that? Happiness is a tough one to measure. Employee satisfaction is a tough one to measure, especially in a quick way. You'd have to have some kind of very well-applied process to measure that. So people do it. People study how to do these things, but you're just going to make sure as you look at a study if it's clear what they did to do those, to measure that. All right. How about confounding variables? I told you there'd be another type of variables in a second. You need to understand that sometimes it's really obvious and sometimes these are really hard to see. A confounding variable is a variable that is not intended to be part of the study, but is, and makes it difficult to interpret the results. So they call them confounding because confound is another word for confuse. So I'm going to give you some examples of this, but we could do examples of this the rest of the day and tomorrow and probably the rest of the week. So let's just look at this one. So let's say a group of students perform better in an online class than in the classroom-based class. Does that mean the online class is better? Well, first of all, better is one of those hard to define variables of interest. But there's a lot of confounding variables here. What else could be different about the classes? So we had to really cut down on cheating in the online environment, and that is no longer the case. Our online classes don't outperform our in-class classes because they're not cheating like they were now. So that was a confounding variable. Another confounding variable is what about the teachers? Like a really great online teacher, should they be compared to a really new struggling classroom teacher? What about just the groups of students? A lot of times your online class students are people coming back to school with experience in the workplace, experience in school, good study habits, whereas people in like a freshman class may not have great study habits. They may not have great support networks, right? So we just have different types of students we should compare here. So there's other things going on than just the location where the class is quote unquote taught. How about, say, for the first example, you did the homework, skipped the study guide. For the second test, you waited till the very last minute, you finally did all the assignments, and then you did better on your exam. Should you conclude from this that it's best to wait till the last minute to do your homework? This is my answer. No, y'all, there's a billion things that goes into your understanding and your grade in a math class, okay? So you might have asked your instructor good questions. You might have already understood the material better. It might have helped you to practice near the exam day, but there might be less reasons to do, or a better way to do that than just your homework. You could have taken better notes during class and reviewed them. You could have discussed a problem with a classmate to help your understanding. It's not simply when you did your homework. That's not it. You could have done your homework the right way and not clicked view an example every single time and used your notes to try to strengthen your understanding. Okay, I've had this conversation with a few people over the years, is why I feel so strongly about this. But just know that just because it works out one time doesn't mean it's always going to work out that way, because there's other things going on. Another thing to talk about is the setting and the wording if we're doing a survey. So remember I told you there's studies, surveys, and experiments. So when a study is done right, it's still important to look at either the setting of the place or the wordings that people might struggle with. So like if I just walked up to you and I didn't know you and I asked you a really personal question in that setting, are you going to necessarily give me truthful responses? Yeah, probably not. How about wording? So let's look at these two wordings. If you asked someone, do you believe the death penalty is wrong? Or how do you feel about murdering murderers? Those both have bad phrasing, right? That's very poor wording. You're not going to get truthful answers here. You're going to get emotionally driven answers. What about if you asked someone whether they favor or opposed the death penalty as a punishment to a capital offense? You're still going to get people who feel strongly about this, but without these wordings that tell you like what you think people should say. Like one of these really makes me want to say yes, and one of them makes me really want to say no, just because that's what the person asking me obviously feels about it. Whereas the second one, the green word, the better wording, is more open and lets me think about it and respond with my actual beliefs, and that's what you want, is for someone to tell you the truth, right? Watch for subtle word differences in statements. So the first one, what percentage of internet dates lead to marriage, or what percentage of marriage begins with internet dates, are very, very different numbers, okay? For one, they're totally different populations. So the first one is talking about everybody that's had an internet date, how many of those have ended in marriage? The second one is of everybody that's married, how many of those started with internet dates? Okay, there's their different questions, different responses, different populations with only slightly different wording. Wording is important. And for our last example in thinking about the wording of surveys, we're going to look at something with lots of problems, okay? So let's say the Republican National Committee commissions a poll to find out whether Americans support their proposed tax cuts by asking, do you favor a tax cut, in which a large majority says yes. Does that mean we can conclude that Americans support their proposal? All right, so there's one obvious problem here. There is bias because the party is invested. I could change Republican National Committee to any political party here, and they're going to have some kind of interest in the answer, right? Especially if it's theirs. Also, this doesn't share any information with us about sampling. So my assumption is how they sampled. If they wanted us to know, if they had done it well, they would have shared that information, and they did not. And the last thing is what we learned in step 6 is this is just bad wording. There are not enough answer choices for one. Okay? Yes or no in terms of favoring a tax cut is too vague. Like, who does this tax cut help? What does this mean for somebody specific? Would you favor it even if it meant you changed to a different tax class but someone else at your work didn't? A good survey is going to give people a lot of answer options, like not overwhelming, but some good, amazing response options, and the option to even state something else if you need to. After everything, when you're looking at the survey results, the experiment results, the article that's been written, were the results presented fairly? So you're going to an interesting thing about misrepresented graphs, but we're going to start with misrepresentative statements. So researchers may misinterpret the results or jump to conclusions that the results don't actually support. So are they linked here? Is what the survey said or the data says the same thing as what the researcher says the data says? You have to watch this a lot, especially if you're invested in something. You get results back, it feels like they say what you want them to. All right, so a survey finds that 80% of elementary students at a local school don't wear a helmet when they ride a bike. You're concerned because people should wear helmets. It's safer, right? So some researchers determined that they must not have helmets, buys 300 helmets from the school, then later does a survey that shows 75% of students still do not wear helmets. What went wrong? Okay, so we don't know anything about the research here, but we probably falsely assumed why they weren't wearing helmets, right? It's probably not that they didn't have them. It could have been, but it's probably not solely that they didn't have them. So it may be true that they didn't have helmets, but just giving them helmets doesn't solve the whole situation. They need to know how to wear helmets, when to wear helmets. They need to be told it's cool to wear helmets by someone who is cool, right? There's a lot more going on here, and they interpreted their results to mean because they didn't have helmets, they needed helmets, and that's it. That's not good, fair results. School Board in Boulder, Colorado creates a hubbub and says that 28% of Boulder students were reading below grade level. So they totally changed the curriculum. Doesn't this sound familiar? But the actual results on a reading test said that 28% of Boulder students scored below the national average for their grade. Are those the same thing at all? They are not. Below grade level means that they're not reading at their grade level. They're reading at least one grade level below them. But below the national average just means they're reading less than the grade level, not the grade level, but the reading level of half the kids in their state. This is actually pretty good news. This is bad news. Okay, slight change in phrasings, especially for people who don't understand like national average and grade level descriptions. These both seem bad, but this means 72% of their schools scored above the national average. So more than half. You would expect half above and half below. So this is good news. The headline doesn't match the actual information. The headline is to grab attention here. Right? And at the very end of it, we should stand back and consider the conclusions. So true research is hard and time-consuming and expensive. And it's important to realize if it actually met the goals or if you need to do something else. Does the conclusions make sense? Are there any other explanations for the results? Like if someone started exercising and taking a drug and they lost weight, does the drug help them lose weight? Or was it the fact that they were exercising? Confounding variable right there. If the conclusion makes sense, does it even have any practical significance, though? So I was thinking about this episode of The Big Bang Theory where they're celebrating, and Howard tells them all they're celebrating because her anti-inflammatory drug is going to be made now. And so they've had 3 years of testing and no reported side effects. Doesn't that sound good? That's the results. It's true. Like, that's good testing. And so Raj asks, so it works? And Bernadette says, Right? So the results were there's no side effects. No one feels worse after taking it. But does it achieve its goal? Is it making people feel better? That's questionable. So you have to look at this. I'm not telling you not to trust anybody, but I'm telling you not to trust data that's presented in a bad way. Right? If people want to be honest, they should share as much about their process as they can, and when people don't share, it makes me question.